Good question. Her question was about my skill chaining of refactor something and then implement, and then when do I check it? Basically, I'm not. It's just a fun project, and I mean that's how it started. It's getting a little more serious now, but I'm probably my first 20 times I did it, I was reviewing every plan and then like feeling really nervous about it. But I've gained so much confidence in the ability of AI to do code review better than me that I think like this scope of these refactorings are so narrow. It's like extract a function into a new file, like just really obvious like developer best practices. I've been able to trust it more and more. For, I mean, for that workflow I was demoing, unless I usually don't really have that much of a specific idea of what I need refactor. I just know I have some like 1,200 line files, for example, in my code base that I. Oh yeah, I mean that one I was showing was focused on refactoring, and that's the only time like I created that swarm, that like idea of like all these parallel agents like taking on tasks, and I was hoping that I would be able to like clearly express my intent up front, but I think it's just impossible to give the AI enough guidance at the very beginning for it to go all the way through a huge project. Like, yeah, I want it to be true that it can just go work for days for me, but I think the reality is like there needs to be some way to stop it and say like, okay, now what? Yeah.
Have you seen any open code use cases that have been done on this one? And I'm asking because I'm trying to find the use case we do, but I
Totally. His question was, have you found any use cases for OpenClaw that are only possible with OpenClaw? For me, no. And I would say like the way to frame OpenClaw, or I think what's interesting about OpenClaw is that like, yeah, 2 months ago, you could have built these things on your own and you would have probably, you have to pick an agent framework. You have to figure out where to deploy it. Like, I think it solves a lot of these problems for you to just have, like, to be able to connect all these services. Like, for example, I connected to Gmail. So I could have created an agent, like, I don't know, an assistant agent, like a couple months ago, where I use like LangChain or LangGraph, and I do a lot of coding to kind of like set up a way to like OAuth with Gmail and check my Gmail, put labels on it, draft replies, whatever you would want a personal assistant to do. So I don't, maybe there are examples, but I don't see it as like an innovation on a technical capability in most parts. It's mostly the user experience of saying, hey, I've connected Gmail. I want you to check my Gmail every morning at 6 a.m., label anything that comes from Luma as junk, draft up replies for anything that's like a personal email. But you know what I mean? It's like you can just with one prompt write software. And I think that's the innovation there. So that's one prompt. I have another one that's like, just give me a summary every day of events in SF. That would be fun with my girlfriend. So I have like each morning, I just have like, it's searching like 15 event sites and just aggregating everything, giving me summaries. Like that was possible before AI or before OpenClaw, but OpenClaw just makes it really easy to go like prompt to complete software. So that's how I look at it. I'll do one more and then let's get the demos going. Right here.
Just about like I'm curious about the cost of experimenting like with these things. It's a range, but what you've described, like what's the cost behind like all these experimentation happening?
Like token costs? I have a ChatGPT Pro account, so and they also actually have two.
It's covered with that.
Oh yeah, totally. And I actually I got a second one because I ran out of tokens like on Friday and had like 17 more hours with no token usage. So it's like, fuck it, I'm getting a second account. And I paid for a second account, and then within 12 hours, they announced the Codex app, and Sam Altman's like, oh, Codex app is out, now we're doubling usage limits. So this month, I'm like 4x more tokens than I had last month. So I'm actually trying to, that's what I did the swarm thing. I'm trying to start as I can to spend tokens. But yeah, I mean, if you have, I think $200 a month is pretty reasonable for anyone. Like, you can get pretty far with the rate limits there. And then, yeah, running OpenClaw on the cloud is pretty cheap these days. You don't need a Mac Mini. You don't have to go buy a new computer. You could just do it in the cloud. But yeah, thank you guys. And yeah, I'll be around after the chat. But let's get the next demo going with Chris.
Yeah, it's it's not like just like it's maybe everyone dimension is like well. Comparing
I can tell you.
yeah.
Well, I did it once, and like, it was actually for 2 years.
Oh.
It's a bigger turnout than the OpenClaw, last week. All right. Well, thanks for this opportunity. I really appreciate the chance to get to talk about kind of what's in my brain. Lots going on. My name is Rick Lopez. I've been a software engineer for a little over 10 years. I always say that's a picture of me before I did my startup. So, founder of Artificial Compute. We've been building AI agents for about 3 years now. Have a master's in applied AI and just been building agents for, for 3 years. So the reason I bring that up is kind of, this is a talk in progress. I think, yeah, I'll just kind of go through. So it's really how do we go from prompting to predictable delivery? And if you're building with AI like at scale and you're actually building with like other team members, the rules kind of change. I don't think that's right. Is it? Yeah. Sorry about that. So I'll just do this one. So I can see why do these principles matter? Like context engineering and AI engineering, why do these principles matter? Why not just vibe code everything, right? And by the way, like how many people have been coding for more than 3 years? Anybody here? Like everyone that raise your hand, you're not a vibe coder. Like even though you're vibing, you're not a vibe coder. You have engineering principles as you're prompting AI. You have these concepts in your head. You're not a vibe coder. So to me, why do these principles still matter? Well, obviously I was watching the talk with Peter Steinberg on the YC podcast, and he's talking about how he built OpenClaw. And you could see he was just going through these engineering principles as he was building OpenClaw, right? And those people exist. Yes, there's people that can just grab Codex, grab Cloud Code, and like 10x results immediately. But what about the junior developer, right? What about our teammates that work on it? They don't have those skills in their brain, right? So how do we codify that? Another recent talk, and this is all what I'm going to show you is kind of based on all these concepts. So we've been here before, by the way. It seems new, it seems exciting, but if you've been building software for a while, we've been here before. How many of you guys remember like the Java and the Java arguments versus Python, or like Python versus JavaScript, right? Or JavaScript versus TypeScript. Like those arguments are the same thing as vibe coders. Like those are the same arguments we had where every generation gets a new language and the next generation says, oh, that's not a real language. Yeah. Oh, make it bigger. Sorry. Yeah, of course. Yeah. Yeah. So this is Mark Andreessen and his recent talk. He said every generation has its argument. So vibe coding is just the highest level of abstraction. Whoever created Markdown basically probably created like the last programming language ever. So kudos to whoever created Markdown. I don't know who created it. But the way I've looked at it, and this talk is based a lot of context engineering concepts. You know, the AI engineering guys and girls do a great job teaching us this stuff. We really look at AI as runtime. It's not magic. It's a runtime. It has rules. It has certain knobs you can turn, and it's going to get better performance. The big one is context, obviously. Managing context today. I like this concept. It's not a. I feel like it's not an engineering topic. You don't quote Martin Fowler. Probably shows my age. But it says any fool can write code that computer can understand. Good programmers write code that humans can understand. We're in a new era, right? I think AI engineers, a fundamental concept there is that we're in the practice of writing plans so clear that humans and AI know what's going to happen before we even execute it. And that kind of hits on some of the questions here. Like we haven't talked about token burn. All these new apps are great, but when you're actually working in like legacy code bases or evolved code bases, like you can't just run autonomous agents for like 5 hours and hope it works out. Like the cost of that's too big, right? So these are kind of 3 laws that I picked up, or that this is what I teach my engineers. Basically, we prioritize artifacts over chat. So artifacts are the new source code, and this is a lot of like with the. When you guys human layer fans? Any human layer fans? So Dex does a lot of talks on this stuff on context engineering. So it's really artifacts as the new source code, and then intent before execution. So we have to agree on the intent before we actually let an agent actually execute our plan. And then agents write the code, yes, but the systems we create actually execute our plans. So all this comes down to the project I'm going to show you, and this is my personal project, it's not my startup. This is the thing that's been in my head. I just work on it every once in a while, so excited to share with you. I think, based on all this stuff that we're learning, don't use prompts for control flow. It's too expensive. Like, buzz phrase, we're talking about deterministic flows versus non-deterministic flows, right? Why not write code? We're all coders. Why not write code to manage the control flow? It's going to save you a lot on token burn. It's going to get better production out of the AI agents. So this is kind of the context engineering, I think, kind of Bible, where, and you hit on it before, right? We just had a step before. We actually really research. We do a heavy amount of research. And that, if you work with teams, on my team, we have 6 engineers, including me. So we'll jump on a call on Zoom and we'll actually put up ChatGPT and we'll actually put it on voice mode, and it's our 7th member. And we'll start collaborating on research. We'll start saying, hey, here's the objective we're trying to do. Hey, what do you think about this? What do you think about that? And the cool thing is we're not bringing tokens on there, right? We're not bringing any meaningful tokens. So we're doing that, and we come up with these artifacts that, hey, here's our research step. And then what we do is we take that research and we create a plan. And then from that plan, then from there, we actually break it up into multiple tasks and GitHub issues. And then from there, we start to implement those little chunks. And then we, of course, validate. So why does this matter? So in college, I was a business major in my undergrad. My master's, I did a applied AI and engineering degree. But I remember learning about like Sigma 6. And like, why can't we apply that mindset to these agents? They're not deterministic. They have an error rate that is actually unacceptable when you think about it in a grand scale. So if you have 99% at each step, so think about sub agents and autonomous agents doing all, if they have a 1% failure rate and you have 20 steps in that plan, you're looking at an 80% failure rate overall in the system. And your whole, that sounds familiar, right? Like this whole, if you guys are doing the whole sub agent thing, which me too, this is why it matters. So the cool thing is, and this is straight from Dax, and the guys over at Human Layer, one of the other things that really helps us out is be really intentional about your token spend. Like every token that we pay for has to bring value to production. That's the mindset that we have. And how do you do that? So there's a lot of different rules and thoughts around this, but today's LLMs, if you keep your context at about 40%, you're going to keep your agent in the smart zone. So our engineering practices, what I'm about to show you, are really about this. Is how do we keep, every time we give an agent or our AI or Codex something to actually write code on, how do we keep it in that smart zone? So all this work before we let an AI go write code for us is really to make sure that every token we spend is actually going to produce value for us. So this is our life cycle. The tool I'm going to show you kind of automates this. So every time we start a project, it's called .prompt. Basically .prompt, say sync my labels, and in your GitHub repo, it'll actually go and put all these labels in GitHub issues for you. And then once you have your plan, you go in there and then you can just start jamming with Codex and say, hey, let's go ahead and create the tasks that we need to create phase one of this thing we're building. And it'll actually go and then create them, and it'll actually mark down. Someone asked a question about where's the human review. So hopefully you kind of see where there's a lot of human interaction with the agent. So here you're negotiating with the agent. Yeah, that is an extra small, or that's a small, or hey, let's break this up into 2 tasks. So you're doing all that before it even writing code. You're doing all that. It goes into GitHub issues, and now you can do the cool things like Ralph Loop. You can do the cool things like autonomous agents, because you can have a rule that says, hey, extra smalls or smalls automatically just go ahead and jam. Just go. Don't worry about it. If it's a bug and it's a P3 and it's a small, go ahead. You can write these rules where, hey, in these certain cases, you can go ahead and just go. And if it's a small, medium, or large, you'll require human review. So that's kind of the idea. I'll stop there. I can talk about this stuff forever, but it's not real if you don't show, right? So the cool thing is, so I'm gonna be honest. I got a call, I think it was today, saying that there's a spot open to talk. So my project was actually based on Claude Code. So this tool I'm going to show you was Claude Code based, but I always had intentions of being model agnostic. So like in an hour, I made it compatible with Claude Code, with Codex. And I've been using Codex. I love Codex. I think they're really powerful, the way it's moving. You mentioned some of the things, the autonomous skills and all that chaining. I think it's important. 3 of our developers are in Ethiopia. There was a reason why we had to move it to Codex too, is because they're not allowed to use Claude Code. So we've been doing this for months, but I wanted to actually implement this into my .prompt project. So I appreciate it. Actually forced me to do it. So here we go. All right. So I'm just doing a to-do app. How am I doing on time?
Say 3 or 4 more minutes.
3 or 4 more minutes. Cool, cool. All right. So let's just go ahead. Let's go ahead. So I did this. It actually wrote my task for me. And I'm just going to show you how I jam. Now, all this would be done with .prompt. You don't have to worry about it. So when you do your repo, so I'll just go in here. You just go .prompt, and then like you could just do sync labels. Sorry, sync labels, and it already did it. So like it would write my labels. You could do .prompt init, and then .prompt, it will write all the commands and skills you need for Codex. So here you would just do Codex, and it would do all that. So with that said, that's how I got to this point. So I'll go here and say, let's go look at my GitHub issues. So I'll say, hey, GitHub issues. It's going to look at my GitHub issues. And it's going to kind of, if I'm a developer on this team, it'll say on this project, here's what's open. And then I'll say, same, looking for stuff ready for dev. And it's using GitHub CLI, to your point, really try. So it says, hey, here's what's available. And then I'll just do the fun one. So I'll just do the Ralph implement. I'll just go Ralph implement. And then I see that this one's, I have a small. Actually, you know what? I'll go, Ralph implement 2. So I'll just say, hey, Ralph implement 2. And this is basically using skills. There's a bunch of skills in here that go ahead and have it implement. It's going to read. So first thing it's going to do, it's actually going to go through the Ralph implement, goes through this whole cycle. It'll research the code base, it'll make a plan, and it'll implement the plan. And then here I have the step here for now. It's just manually validate, but it's not really manual. I have the Chrome MCP. That's like the one MCP server I do use a lot. Is where I'll just say, hey, go ahead and test this out. The cool thing is my test case is already in my GitHub issue. So it just reads the GitHub issues and runs through those test cases on there. So this is kind of how we automate best practices for getting the most out of these agents. You have a lot of commands. So all these are just commands. And the cool thing is, as of today, they're all agnostic. So they work the same on Codex and they work the same on Claude Code. So that's kind of my project. I'll leave you with this. If you're not watching this talk, AI that works, this is Dex and founder of BAML. They actually show a lot of these principles, and that's really where I got inspiration from. I couldn't get access to their beta, so I got their open source project on Human Layer. looked at their skills and actually built out prompt and basically had our team kind of follow the same flow. So last thing I'll show you, this was a more recent project I was working on. This is what a plan, this is like what the top level plan looks like. It's called a pitch. So we make a pitch. This is, you're kind of setting the context, right? For like, what are we actually building? And then without prompt, you actually get templatized, you templatize these two artifacts. And then after that goes the technical direction, like what's in, what's out, what can you use, what can't you use. So those two artifacts are the top level, and then everything else becomes research. So you'll see you'll have research, it's researching task, and then after the research, you have the plan to implement. Then this is how the agent looks to actually implement stuff. And all this is designed to keep you in that smart zone, keep your agents really tight in that smart zone and not burn your tokens. And why does that matter? You probably, more than how awesome AI is, this is probably what you see on LinkedIn now. People talking about how much tokens they're spending and they didn't realize it's gonna be that expensive. So big part of this is be intentional with every token, make sure it brings value to your business. That's it. Any questions?
We'll leave questions till the end because we have, I think, 3 more people going. So if you have questions, hold them, and then you'll get to ask Greg one-on-one. Next up, we have Vince.
No, I just turned it off my phone.
I think you need to be on Wi-Fi. But actually, if you can pump up,
Hopeful Bob.
you're displaying from your phone.
No, my tethering phone. Like I said,
So I'm seeing you connect to those projector.
yeah, sweet.
Sweet.
How do I get this going? How long do I have? Do something. My screen. Do I need to screen share to the airplane?
I mean, I think you should.
Like,
Well, can you use HDMI too? Did you get HDMI going?
I can just, I've got it plugged in, but I can airplane as well. So just.
Let's see. If you can, well, to airplane.
That's nice. It didn't detect.
That's it.
So it's used to switch to. I just switched to Wi-Fi. Sorry. Sorry.
He's going to
Play it.
Yeah, and it's enterprise underscore Greg. You felt like a plug for your student. So. Good. Oh, you display settings?
I usually just fix it up.
Bigger.
Technology, man. They have like robot parts and everything, but
He's,
can't switch.
you can see it, you can see it in the quick one now.
It's rebooting. Sorry. There we go. Came to 7, 5, and make sure it explodes. Beautiful sun. Let's see about birds. And it's not so nice at all. Okay, so actually I will like in the promise this is going to work. That's fine. No. Okay, welcome everyone. Let's go. All right. So my name is Vincent. I'm going to talk about automatic agent optimization and the rise of self-moving agents. This is like my research area. I've been working in the space. I'm going to go insane speed. Because the part I want to get to is the demo, but the demo is parts of the demo are not going to make sense without context. So struggle. A little bit about me. So I work for an open source telemetry and debug company called Comment. We built something called OPIG, which is an open source product that you can do telemetry around. I'm also an adjunct professor at MIT, and as of recently, I'm also one of the few maintainers of OpenClaw. And that wasn't by mistake that we both ended up here. It's kind of funny, but oh no, you can see all my slides. Let's go. It just works. Stop doing this to me. All right, 1 second.
You can start, please.
I really apologize. Slideshow. Send you. Slideshow. I'll have to do it this way. There's a bug to us. The top left. I figured it out. Sorry, I put their name. Sorry about that, guys. So yeah, a little bit about me. Yeah, I mentioned I am obviously working on episode telemetry, MIT, but also as of recently, so one of the maintainers at Open Core. Crazy times. That's me.
Talk into the mic a little more.
Can you hear me now?
Yeah,
I'll just hold it. It's gonna be easier now. So a little bit about the side project thing I've been working on, which is around self-optimizing agents, was essentially like agent optimization or prompt optimization on steroids using open source methods. It's things like Gepper and things like that. But this is public. It can tune prompts. Now, the interesting thing about tuning prompts, it can also tune agents. It can also tune MCP tool signatures. And as of recently, I've also been working on Kelvin Applied for skill tuning. I'm not going to show you the skill tuning. I'm going to fly through this thing, and I'm going to show you like how I've applied skill tuning methodologies, because it's something I'm still kind of working on as well. Essentially, when we're building anything AI or otherwise, we have this like illusion, it's like this impossible triangle. We can't have everything, right? And it's this kind of simple trade-off between speed, cost, and accuracy. We talk about like wiggle loops and all this kind of stuff. Yeah, we can have a model, we can have an agent that's like crazy accurate, but it's going to come at a cost of speed or trade-off between speed, cost, and these other things, right? So we can have things running for absolutely ages forever, but what's the quality going to be like, right? Or it's going to cost you a lot of money. And yeah, when you apply it to something like Wiggum, yeah, it's going to run for ages. And I think these are sort of the trade-offs and things that we have to sort of think about. And sort of bit of in context, right? Like 2022, we had prompt engineering. Then we had this thing called context engineering, which is essentially just search. We brought it into this modern world, those LLMs, and whoop-de-doo, it's like this cool thing. Some of it's quite smart. I'm not playing it down. But what we're sort of leading into this like concept of like intent-based engineering. And what I mean by this is that we start with the output of what we're looking for, and we look backwards, and we pick the right models, we pick the right agents. I honestly don't care how the system is building that thing. I just want this output to behave the way I want it to, and you just get me there, right? Prompt engineering was essentially what I'd like to call doom wordsmithing. We would just bash all kinds of garbage, like, I'm going to kill you, my mother's going to die, we're all going to go to hell, I'm going to give you $400. It's crazy. Honestly, it's insanity. Look at some of the IDEs, source code, and the system prompts in there. It's some wild stuff, man. Context engineering is like, look, let's just inject stuff into it. But intent engineering is like where machines can kind of self-optimize. I think people that have touched OpenClaw can kind of feel this. And like, why is it different from anything else? Well, it can write skills as you're talking to it and change its own system prompt and things like that. And I'm basically saying like the elephant in the room, aka the lobster in the room, is that like intent-based engineering is very real. Even though it doesn't feel like engineering, there's like cycles and loops, but it's kind of happening by itself perpetually. Like it's just something in my control. We can have an agent, system prompt, user prompt, we can have tools, we can have the model. We have those components that we work with, right? But when we work with prompt engineering, we go like, why is this model hallucinating? Right? We have a system prompt, we take the prompt out, we get a new prompt, we stick it in. But we vibe check it, but there's no signal. We don't have that triangle. We don't know like what good looks like. We don't have any sense of like, is this accurate or not? We have no sense of telling like what the hell's going on, right? So it's flawed. But if I write a better prompt and I test it, I have some signal in there, and I can loop through a big data set, that is some form of optimization that is essentially occurring, right? To fast forward, this is like a more complicated process where you have algorithms doing this, where you'll go through, run the prompts, find issues with it, create new prompts, patch it, all this. The package is out there, it's open source. Come talk to me afterwards. I can show you this. We can apply it to MCPs. But in theory, we can apply this to skills, because all skills are is essentially a user prompt and a bunch of tools encapsulated together. Now, the beautiful part is I've been using a lot of OpenClaw, but the skills it creates is like, I'm not saying they're bad, but they're just sticky tape stuff, right? Like it kind of works, but it's not great. So for me, it was like, how do I alter this process a little bit more? There's some recent research from, I think, Berkeley, correct me if I'm wrong here, where essentially skills don't, like there's no added benefit of a machine creating a skill. It's just, there's no upside. But if a human creates it, it's really good. So I kind of went on that journey a little bit. And some of the things that I've been sort of working on that recently was like, well, my data is trapped, right? My data is trapped inside of all my past chat logs and stuff like that. So this was a hackathon entry I did a couple of weeks ago in SF. And yeah, it was like just this is all open source, you can grab it as well. And it's, oh, jeez, dude. There you go. So this is one of the projects I created called Open Amnesia. And the idea was that, well, we have an open claw instance, but it has amnesia. When it starts as a starting point, it doesn't know anything about me. I have information inside of my iMessages, I have information inside of like maybe 6 months of like Codex logs. Can it go through that and find moments that look like potential skill opportunities or repeat patterns, extract that and create skills? I couldn't get to the point where I'm like completely automating this process, but the parts are there, right? So you can kind of see where we go with this. But what I did to kind of show you guys an example of what I worked on was actually I wanted to take an existing skill that I had and sort of revamp that. And this skill is called technical documentation. And it started off sort of okay. Originally, it was like a slash prompt to rewrite technical docs inside of a repo. But this thing was like not good. And you can see I started creating a bunch of stuff. And I'm going to kind of like talk to some of the tricks and things I'm doing. Very different, but somewhat similar to the demo earlier, is that I've noticed that, you know, with OpenClaw, I can say to it, this agent has access to these models. It has access to these sub-agents and things like that. But the beautiful part about a skill, yes, it's a skill MD. It has assets, it has agents. But you can also say, for this type of task, use this model. For this type of task, use that model. And that's where it starts to get referenced. So in this particular example of technical documentation, there's like the principles, it has like all these tasks. It has like examples it goes through. I will run it in a second. But I have to find the sub-agents as well. And when we run this, when it starts picking out the task, it will actually start executing those sub-agents as sub-agents, which I toyed with and surprisingly worked. And I have actually defined inside of the sub-agents what type of model it should use, Sonnet or like equivalent, like, because we don't have that equivalency in GPT, but like understanding there's a smaller model, a faster model. In some of the other agent files I have, I've specified go think more, think less, go fast, and sort of what tools you have. So in this particular example, the skill, the unique thing about this skill and my authoring process, without going too crazy into like detail, is if I go into my Claude file of one of my Claudes called Samantha, she lives inside of my iCloud drive. It's totally synced, async. I'm not going to get into the madness behind it, but it means that I can author the skills from my end and it syncs to all my OpenClaw agents. But this is one of the ones that I was working on recently, and I was like, create me one for Equinox Gen. And yeah, it created this like insane JavaScript file and one skill empty. I'm not happy with this, but it's a good starting point. Or if I take my logs, like I said, I create a skill, I'm not going to be that happy with it. So I want to sort of author that process. And what I've essentially done in this particular example, I created this .skill folder, which works like similar to dot files, and uses Vercel's npx skills library and syncs these skills. Essentially, I have like an authoring process. I have a test in here. I have a spec in here. So there's additional stuff attached to the skill that gets automatically done. So I can one shot it, deploy, and automatically inside of here they come up, but also they'll appear inside of my Claude agents as well. So initially my Claude agents might build stuff. I might take that out and build like a bit of an IDE process. I've submitted some bugs because I was changing skills so much and testing it. I was actually noticing bugs where the skills weren't loading. And the Codex team resolved some of those today and made a new release. But essentially, the workflow for the gym in a very rudimentary way would be me taking that technical documentation one. So let's go here. I'm going to test this live. I'm just going to say, go rebuild the firm docs, right? So that will go off, create sub agents, things like that. On the flip side, I will go back into the agent skill and say, here's the work tree where it's working, and here is the session. It's not working well. So this was me running this yesterday, tuning this thing where it was going through and like changing the skill based on the live session. If you had them side by side, it would look a lot nicer. So here, this is it sort of running, and this is something I've been using quite a lot. There you go. I have the command chain ready. So it's actually kicked off sub agents and started chaining them together. And this thing is like massive. It'll run for a while. I have a video on X where this thing is just like created an insane amount of change. And let it run, but I'll show you what a PR would look like quickly. My team is still reviewing this PR. This is not for OpenClaw, but for OPIC. Yeah, I've got 100 open PRs. That's just from the last 2 weeks. So when that actually ran and finished, this is the amount of files it changed, 57 files. It was changing docs, but it was mostly changing the agent files within this so that the .agent files within repos and the docs and the code will work well together in a large mono repo, that they all sort of make sense. So you can see here, the skills are getting edited, the hooks are getting edited. Like this is all just being done, like a massive change. I had to run it a few times and stuff like that, but it will sort of go through. It's going a little slow, but yeah, keep that running. So the process for me is like create this, like either in my OpenClaw, go off, it'll do something, it'll build something hacky, and then I take that skill out and I go through like a live environment where they say essentially this becomes the IDE almost in a way, and I'm testing that skill firsthand. I'm authoring it, seeing what happens, and like human in the loop, sort of like making a better skill. And then eventually I could wire in those like optimizers that I showed you, which would essentially like 10x the skill based on my human preference. It could have code in it, it can have other elements like that. And then it's the authorship process where I would just go in and go, hey, in my skills, my agent skills, hey, let's go off and yeah, it's saying nothing's produced because I've obviously fixed a lot of these problems, but it will go off and create like a deployment of that. So then if I go into here, I would just have to run this npx command, which if I showed you what that looks like, it will run, it will go to the Git repo, pull it, and you can run this on any node instance, and you can see it's like automatically symboling that skill. So I can just be changing that, and on the other end, my agents deployed anywhere will be constantly polling this when they get a new update, they'll just download the new version of the skill. So I'm able to like on the fly update my core repository of skills. And the thing I want to do is attach the skill to the sub agent or the agent. So there's sub agents, agents like, you know, within the skill. But the only difference I do with my OpenClaw is that I have like specifically defined agent with a role that the skills are attached to. So I don't have like this mess of like 100 skills going to like all these places. Yes, there's 100 skills deployed, but I'm specifically saying these 4 skills are only used by Samantha. These 4 skills are used by Jen, blah, 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 blah. One feature I think Codex is finally releasing is sub agents, where essentially is this process that you'd be able to do this and you can say how many children you can have, and you'd be able to define which skills and stuff go to which agent. So similar concepts that we have in like OpenClaw will exist inside of Codex. My whole preference is to basically take a lot of the domain knowledge that I have about a particular problem, like building documentation and creating like what's best practice, converting that into like a simple skill with code and stuff like that, but almost having that in a way that's packaged, testable, refinable, optimizable, and like deployable. Like I'm almost treating this like almost like software in a way. Originally, like when you were building agents, you would do this with prompts and things like that for your agent and sort of deploy them in weird ways. So I feel like we've kind of gone full circle into that loop. Yeah, so that's my workflow. Thank you. So I went rapid speed on that. Want to do questions at the end?
Yeah, let's hold up questions because we still have 2 more. If it's quick, what you got?
It'll be super quick. I just wanted to finish that last thought of yours. You're talking about like having that be software for you. I was just reading in LinkedIn where people are now taking that, what you're talking about, and having it compiled into Python code, and then only running the Python code. So
you could use Python, it could be it honestly doesn't matter, whatever it is, but it's the arbitrary set of rules of what the agent should have, how it should behave. And it's more closer to in military they have standard operating procedures. In like it's very like procedural, but like written out in human form. And if the case is like, oh, to do your job, you need to drive this truck, that's probably to be a Python script for it to do its job in this case.
Sure, but what I was talking about.
Let's just, we have two more demos.
Sorry.
We have two demos and then we're gonna have like 10 minutes for networking. We have to be out of here by 8. So let's do it soon.
All right, guys, so as you might have heard, I'm Sam. And I think I drastically misunderstood the assignment here, but we're gonna do it anyway. So I am an AI engineer at Hone AI, which is an open source automated agent monitoring and evaluation system, a lot like the other guy. Doesn't matter though, because I also just started a podcast. That's what we're gonna talk about today. All right, I like that. We'll do that later. Okay, well, let's do some crowd work here. Who wants to talk? Does anyone want to say anything? Or anyone not shy? Give me a hand. One hand. This guy in the red. Do you know who the mayor of San Francisco is? I'll give you a hint.
I didn't get to which I was.
Okay, well, this is the mayor of San Francisco. Does anyone know him? Does anyone? That's not the mayor of San Francisco? We got smart people because that is actually the president of Wendy's Hamburgers. Peter, I don't know how to say that. This is the real mayor of San Francisco. So you guys, you're going to love this podcast, right? So what I think is that sometimes in San Francisco, we kind of forget about, like, we all know Peter Steinberger, but I didn't know this guy. Honestly. I didn't know that a hamburger guy either. But I guess I don't have to. So I wanted to make a podcast about people, like the people of San Francisco who make this city great and livable for all the people who care about Peter Steinberger. So I made the local podcast, but I then decided that I would write a bunch of software for it. Because who wants to upload something to Spotify? Not me. I want my agents to do it for me. So this is what I thought the assignment was. We were gonna talk about cool ways we use Codex. So I use Codex. I give it the files, my raw files from the podcast I just shot, and I made a skill. I think this is a dumb idea, but I did it because peer pressure. And you can just run it. We'll run this will run in real time in the background. It'll take a little while, but I did it before this so that you guys wouldn't have to sit through it. And you can see kind of the outcome there. It also made me a front end, which is really nice of it. Sometimes there's a little peer pressure from these guys to use the front end that they make. Where'd that go? Okay, here it is. So, this is another part of our podcast. We do it outside on the streets. But I did some iteration with Codex about this. And how it goes is the stuff comes on, it does a bunch of ingestion, it does a bunch of rendering and stuff. And then I select the 2 frames for the 2 speakers. All right, you guys, we got no audio. But it'll do that, and then it transcribes everything on the back end, picks out some shorts for me, and then makes you guys, you like AI slop? This is like AI slop, but made by humans and also AI. Which I guess is what AI slop is. So it makes the slop, and then it does a schedule of deploying the slop, which it didn't get to yet. Across my different channels, which I provided a link tree for you guys. Is this it? Yeah. Nobody's scanning. But that's gonna be the
I'm a podcaster, so I'm scanning.
the socials and everything. I'm taking it down for I'm done. Y'all. But yeah, this is gonna keep going. But basically, what's cool about this is I can also chat. Like it made me another sub agent. Oh dang, what happened? Oh, guys, this cool new website that has anything you want called localhost 3000. Looks like it crashed. But I would highly recommend it. But there's that other guy was talking about agents, the important ones, but like the agents that I use for like coding that are like general, I wanted to put up these like rules for how I like to use them. Oh, there you go. There's my favorite website back. Oh. Guys, Codex is crazy. I think that's actually what happened is probably, remember when I said I was going to do a live demo, which is always the best idea, is probably restarting my whole server. Yeah, that's what's happening. Hey, President of Wendy's Hamburger in the house. Where are we? Okay, rules for your agents. I love talking. That's the trick. I love talking to the agents. I think that that's like one of the biggest things that's a problem with AI, with agentic coding is people are not putting enough context into the agent. And so I use an open source software that my friend made called Vocwell, and I just like talk for an hour in between the different iterations that me and my coding agent take. Use the context to the best of your ability or to the best of its ability. Steinberger was talking about this one too. But like once you're done building something, you should always have it go back, make optimizations, make documentation, and do some refactoring. And then this is the thing that makes me really annoyed when I'm working with people. They're always like recycling, like trying to make things modular and composable in the AI age, which I don't think is necessary at all. Like just build a monolith and throw it out tomorrow if it's not what you're gonna need, because if you build something else in the future. Okay, but for agents that do actually matter, that's my job, honeagents.ai for your production agents, for like ongoing monitoring and automatic evaluation, basically capturing a bunch of context up front from your agent and then building that into an automated evaluation system. Guys, I don't know if I have anything else for us. Oh, Vocal. If anyone wants free voice stuff, because there's like Willow out there, but you pay $15 for that. This is local and free. And this is local and free. This is my podcast. And that's still done. You're done. Yeah, good. You needed an exit. There will be no questions. Not allowed. Who's next? All right, let's see. Cool. I don't have any slides, so I'm gonna hopefully be a little bit quick here. But my name's Chris. I've been an engineer, software engineer, focusing a lot on like iOS, but also full stack stuff for like 10 years. And what I've been focused on a lot lately is how to try to get the agent to validate its own work and relieve some of the pressure on the humans who are trying to figure out, what all they're doing. So quick question. This demo is about iOS. I think the principles are applicable more broadly, but do we have any iOS or like React Native Flutter engineers in here? Cool.
And how many people who are doing like AI coding are using background agents? Like just, yeah, connected to Slack, like let them fly. Yeah, cool. So what I've been hearing a lot lately is like background agents are coming, like you see, a lot of software companies, I think Ramp said that they get like 50% of their diffs come from background agents now, which is crazy. But a lot of teams are really like stuck on, hey, what do I do with this like massive pile of PRs that we've got to review now? And so I'm going to show a couple of different techniques that I have for trying to relieve that burden. So on the right, I have this like little app, like toy app I built. It's like a Claude code agent that I chat with and ask questions about iOS, and it can do like web search or look at the Apple Docs to answer my questions. And so I'm going to do two things on it. One, I'm going to add search and have the agent kind of prove that it did that right. And then I'm also going to fix this bug that's here. So if I say like how to use UI button iOS, hopefully this works. The way it's supposed to work is that it comes back and says like, hey, I can do a web search for you, or I can do a search in Apple Docs, but there's a bug. So like you saw the buttons maybe flashed real quick and now they're gone. So yeah, it was vibe coded and that happens. First, I'm gonna come over here and have this agent kick off. I've got two MCPs installed. One is Xcode build MCP, which is what this agent will be using. And it gives the Codex control over the simulator, so it can click around. It's kind of like the Playwright for people who are doing web. And the other cool thing that it can do, it takes screenshots and it can even take a video. So I'm going to have it like implement the search and then take a video to prove that the thing is working. And like ideally that would get attached to like the diff or something like that, the PR that comes in, so that you as a reviewer, it's just like reviewing how you want to review other humans' work. Like, hey, you did UI work, show me that it actually works. So we're going to kick that off real quick. And then over here, this bug, I have, this is a tool that I've been working on recently called Quick Fix, and it sits up here. And I've already saved this bug as a test. But the way it works, it records everything that you do in the simulator, including the initial device state and all the network requests that leave it and all the responses that come back in. So it can replay that entire session deterministically, like whether your backend is down or whatever, like all the state is like packed into the test. So I've already got a test saved with this exact same scenario. And I'm going to just tell it to use that last test that I recorded to make sure that the fix worked. So have any of you that are doing iOS, have you heard of Xcode build MCP before? Yeah, so I think like I think more people should know about it than they do. But I keep running into people who still don't even know that like you can drive a simulator the same way that you can drive a browser. Yeah, I wanted to share that tool. But then let's see. We've got another simulator popping up now. So this is a quick fix one where it's going to be replaying that flow back and having it test for whether the bug is fixed. And yeah, it's going to run the test first. So I might cut this off a little bit early, but it's running the test, which it will see basically the screenshots and see that the buttons aren't there, and then it should fix it and go back and rerun the test. The cool thing with this is that it gets screenshots after every single action that is in the test, and it can compare the new version versus the baseline. And because all the stuff like the networking and the like initial state is the same, you won't get any kind of flake. So it's very easy to see exactly what has changed. And let's see, how are we doing over here? We've got a search bar now. Oh, we got stuck. The backend server is already running. I really want to see it make the video. Does it actually work? It works. But let's see if it will make the video. All right, and back over here, we are running the test. And so I'm also like really lazy. Typically, I don't use work trees, and I probably should. This is like the test feedback. We can see it flagged the first view is changing now because we've got a search bar there. And everything got shifted down. But basically nothing else has changed. It hasn't fixed the bug yet, which is back here. There's still no buttons. So hopefully we'll see that and get after it. But yeah, typically I don't really use work trees, which is probably bad. I think that as you know, the ability to have these things validate their own work, it's better. Work trees and background agents is something that I will start using more. But I like these little tedious tasks are super annoying to me because I have to sit there and babysit the agent a lot. And typically, if when I want to be hands-on with the agent, it's more when I'm doing exploratory work where like it's a little bit unclear to me how the feature should be built or exactly like what I want to do. I have like a kernel of an idea, and then I want to work with the agent to kind of flesh that out. And so that's where I really want to spend my time is like sitting with the agent, making a good plan for that before I kick it off and then go like start on another plan. And typically I end up getting stuck with checking their output. Cool, so it looks like we are getting, it's testing it. Let's see. And it's taking screenshots. So that's nice. So it's like documenting the different states. And over here, it has found the root cause. And let's see. And it's looking at the payload shapes from the WebSocket. So it will make that fix and probably rerun the test and see that everything is working now. But I think this kind of wraps it up. That we've got video records and snapshots on the one hand, and on the other hand, like a clear diff between before and after, showing that the bug is fixed and nothing else changed. Yeah, that's it.
Thanks, man. Thank you, everybody, for coming. We have 10 minutes. If you have questions specific to Chris, hit him up. He's here. But we have like 10 minutes to hang out, grab a drink, finish the pizza. I think it's some more pizza. If you demo it tonight, send me your slide deck and I'll share with you guys all. And if you want to present next time, send me an email through Luma. Or if you want to connect, do the same thing.